Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called The Circle of Sudoku Life by Doc Logic. Sorry, I was trying to do a Circle of Life reference from The Lion King. But anyways, that didn't quite work out that well, but let's get to the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 such that there are no repeats in any row, column, or box. We have digits in cages add up to the given sum. So these are normally called killer cages. So for example, these two digits must add up to 6. And actually, I guess this is why it's called the circle of Sudoku life, because we have a circle with these two digits adding up to 3, these two digits adding up to 4, these two adding up to 5, 6, 7, 8, 9, 10, all the way up to 17. And then it repeats itself. So as an example, you could have something like 3 and 5 here, and that fills this killer cage Sudoku, because they both add up to the 3 and 5 adds up to 8. And that's how killer cages work. We also have crop key, where cells linked with a white dot are consecutive, and cells linked with a black dot have a ratio of 1 to 2, and not all possible dots are given. So as an example, if this were a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive. And if this were a 4, this would have to be a 2 or an 8 to make sure that these two digits are in a 1 to 2 ratio. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the first thing that I see then are the killer cages that add up to 3 and 4, 17, and 16. There are only one set of digits that are allowed to add up to 3, to 4, to 17, and 16. And to add up to 3, it has to be a 1-2 pair. To add up to 4, it's a 1-3 pair. To add up to 17, it's an 8-9 pair. To add up to 16, it's a 7-9 pair. Well, this 1-2 pair eliminates 1 and 2 in the rest of the box and the row. So this cannot be 1 and 2 adding up. You cannot have 1-6 adding up to 7. You can't have 2-5 adding up to 7. Therefore, this is 3 and 4. That means also this 1-2 means this can't be 1. So this is 3, which makes that a 1. This pair of digits adding up to 5 then must be 2 and 3. This pair of digits adding up to 6 cannot contain a 4, so 2 and 4 is eliminated. Therefore, this must be 1 and 5. This can't be 1 because of this 1, so this must be 5, which makes this a 1 here. This digit cannot be 1, 2, 3, 4. It has to be 6 or 8, which must be with 3 or 4 to be in a 1 to 2 ratio here. This 7, 9 eliminates 7 and 9 in the same column and the same box. So this can't be 9. This is 8, which makes this a 9. This can't be 7 or 9, so this is 6 or 8, which forces this to be 7 or 9. The remaining digits here in row 3 have to be 5, 6, 7, 8. The two pairs that can be add up to 14 are 5 and 9 or 6 and 8 here. We're not sure which. Either way, one of these requires a 5. The other pair would require a 6. So if we try to have a 5, 6 here, that would not work because that would remove all possibilities for this cage. So this has to be either 2, 9, 3, 8, or 4, 7, adding up to 11. Well, these digits are in a 1 to 2 ratio with another digit, so this can never be 7 or 9 here, which means this can't be 2 or 4. Let's continue with this, actually. This is easiest. This digit is in a 1 to 2 ratio with two other unique digits. So the only digits that's possible for is 2, which is in a 1 to 2 ratio with 1 and 4, or 4, which is in a 1 to 2 ratio with 2 and 8. So this is 2 or 4. If this were 2, it would have to be 1 and 4 here, but this would then be 1, and this would be 4, because 1 could never be here. But if this were 2, it would have to be between 1 and 3, and therefore this would be a contradiction, or it would counter normal Sudoku rules, because 1 would be here, and then 1 would also be in the same box here. So this can't be 2, this must be 4, which means this has to be 2 and 8 on the possibilities here. This has to be a 3-5 pair surrounding the 4. That eliminates 3, 4, and 5 in the rest of the column. So this can't be 3. This is 2, which makes this 3. This can't be 5. This cannot be 3, 4, or 5 here. Well, these possibilities are 3, 9, 4, 8, and 5, 7. So this must be then 7, 8, or 9, which makes this 3, 4, 5. But this can't be 5 either because of this 5. Therefore, if this can't be 5, this can't be 7. So this is 8 or 9 here. We have a 3, 4, 3, 4 pair in column 7, which eliminates 3 and 4 in the rest of the column. So this can't be 3, this can't be 8. This is 2, 3, or 4 here. This possibility is either 4, 9, 5, 8, or 6, 7. But if this were 4, 9, that would eliminate all possibilities for this 12 killer cage, right? If 4, 9 would eliminate 4 and 8 and 3 and 9. And 5 and 7 is already removed because this is 3, 4, 5, this is 5, and 5 cannot be either of these cells. So this cannot be 4, 9. Let's see. 2 cannot be here. 2 has to be one of these 2 digits here. Remaining digits in column 7 are 2, 6, 7, 8, 9. Well, this can't be 8 here. If this were 2, it could be consecutive with 1 or 3. That seems okay. If it's 6, it cannot be 7 because that would eliminate all possibilities for this cage here. So it would have to be 6 and 5. If it's 7 or 8, it would have to be with the other 7 or 8. And it can never be 9 because then that would be 9 and 8 here, and that would eliminate all possibilities for this cage. So this cannot be 9. What other things do we have? Column 6 has to be, the remaining digits are 1, 6, 7, 8, 9. So this is 6, 7, 8, 9 here. And one of these is 1 with 6, 7, 8, 9. Well, what are the remaining digits actually in this box? We have a 1, 5, 6, 7, 8, 9 sextuplet, which leaves the remaining digits to be 2, 3, and 4. And this can't be 3, so this must be a 3 here, which forces this to be a 2, 4 pair here. This 2, 4 pair eliminates 2 and 4 in the rest of the column. This can't be 2, so this is 8, which makes this a 2. Neither of these can be 2 because of the 2 in the column. This then can't be 1 or 3. This 2, 4 pair eliminates 2 and 4 here. Where is the 4 in this box then? It has to be here. So this is 4. That leaves a 4 in one of these cells. This has to be 6 through 9. Cannot be 8 here because of that 8. This can't be 8, so this can't be 5. Where's the 2 remaining in column 4? It has to be one of these 2 cells. We know 1's one of those. So either this is 5 and 6, or this is a 7, 8 pair here. That means if this is 5 and 6, that forces this to be 7, 8, which means 7, 8 cannot be in the rest of the column. Sorry, the rest of the row. If this is 5 and 6, that also eliminates 7. That makes, sorry, if this is 7, 8, that makes this 6 and 9. So 6, 7, and 8 cannot be in the rest of the row. Therefore, we know 6, 7, and 8 cannot be in the rest of row 7. So this cannot be 6, 7, or 8. It can't be 9 here. This is 1, 2, 4, 5. This can't be 6, 7, or 8. It could be 1, 9, and 2 or 4. If it's 1 or 9, that would force 1 and 9 to be here. But 9 cannot be next to a black Kropke dot, because if we 9 is double 4.5, which is not a normal Sudoku digit. And if we double 9, you get 18, which is not a digit. So this can never be 1 here. If this is 2, it could be 8 here with 4. So if this is 9 and 1, this has to be 2. If this is 2 and 8, this has to be 4. If this is 4, this has to be 6 and 3. Well, we have a 2, 3, 4 triplet in this lower right-hand box, which eliminates 2, 3, and 4 in the rest of the box. Therefore, this can't be 2, 3, or 4. This has to be 9, which forces this to be 1, which makes this a 2. This 9 eliminates 9 and 2 here. 3 and 4 can only be with 6 and 8 remaining in the rest of... in a 1 to 2 ratio, because we don't have a 2 available. This 7, 8 means this can never be a 7, 8 pair, because that would eliminate all possibilities for this cell. So this must be then 5 and 6, which makes this 7 and 8. This 9 means this can't be 9, so this is 1. This can't be 1. This can't be 6 because of the 6 in the box, so this is 8 and 4, which makes that 7. That makes this 3 and 9. So 9, this can't be 5 and 8 here. That becomes a 6, 7 pair, which eliminates 6 and 7 in the rest of the box. So this can't be 6, 7, or 9. This is 8. This can't be 6, 8, or 9. So this is 5, and this is 9. This can no longer be 1 or 5. This can't be 4 because of this 4. So this is 2, which makes that 4, which makes that a 2. This can't be 6 or 7. This can't be 6 or 7, so that forces this to be 9. That forces this to be 8. This cannot be 3 and 5 added together. It cannot be 2 and 6 added together. Therefore, this is a 1, 7 pair. The 4 eliminates 4 here, so this is 3. This is 4. This can't be 2 here. Where is the 2 in this box, then? It has to be here. This 1, 7 pair and the 2 and 8 eliminates 1, 8, 2, 7. So this could be 3, 6, or 4, 5 here. We're not sure which. So this is 3, 6, or 4, 5, but this can't be 4, so this can't be 5. This cannot be 8 or 9 here. So we have a 6, 7 pair in this upper middle box, which eliminates 6, 7 from the rest of the box. So this can't be 6 or 7. This is 5. This can't be 6 or 7, so it's 9. This can't be 5, 6, or 7, so this is 8, which forces this to be 6. Therefore, this is 3 to maintain the 1 to 2 ratio. That leaves this as 4 and 5. And this must be a 6 remaining because that's the remaining digit. This 3 eliminates 3 here, so it's a 5 and 3 here. This 6 eliminates 6 here, so this is 7 and 6. We have only a 9 remaining here. This is 7 and 8. This must be 4, 7, and 8, but 7 and 8 are eliminated by the 7, 8 here, so this must be 4. This can't be 8, so this must be 7, which makes this 8, which makes that a 7. Remaining digits here are 5, 6, and 8. 8 cannot be either of these, so this must be 8. This is a 5, 6 pair here. Remaining digits in row 8 are 3 and 6. Remaining digits in row 9 are 1, 4, and 5. And this can't be 4. Remaining digits in column 5 are 1, 6, and 7. But this can't be 6, so this is 1 and 7. This is 1, 6, or 7. Remaining digits in column 4 are 2, 9, What else do we have? 2, 9, 6, and 7. But this cannot be 9. This can't be 2. This can't be 6. Remaining digits here cannot be 4, 7, 8, 9. So it could be 1, 2, 3, 5, and 6, but 3 and 5 are removed by this 3 and 5. Where is the 3 possible in column 2 now? It has to be here. So this is 3, which forces this to be 6, which makes that not a 6, so that's 5. This is 6. This can't be 6 anymore. We now have a 1, 2, 1, 2 pair in column 2, which eliminates 1 and 2 in the rest of the column. So this is 5. This can't be 5 here. This can't be 5 here. We have a 1, 2, 6, 7 quadruplet in row 4, which eliminates 1, 2, 6, and 7 from the rest of the row. So this must be then 4. Remaining digits here are 1, 3, and 4 in column 1. This can't be 3 or 4, so this must be 1, which makes this a 4. Whoops. Makes this single one a 4. This is 1. This has to be 3. This 1 eliminates 1 here, so this is 7, which makes that a 9, which makes that a 7. This 1 eliminates 1 here, so that's 2, 1, 2. This can't be 7 or 9, so this is 2. This can't be 7. This can't be 7. This can't be 2 or 7, so this is 6. This can't be 6 or 7, so this is 1, which makes that 7, which makes that 1. This can't be 6 or 7, so that makes that 9. The 6 eliminates 6 here, so that's 7 and 6. That leaves this as a 6 and this as a 5. And that's how you solve it. Yeah, I'm not sure. I just sometimes just go by instinct here. Obviously, these were very restrictive, so therefore these were obviously places to start. Anytime you have a black crop key, anytime you have a digit which is next to 2 black crop key dots, and those cells see each other, you know it has to be 2 and 4, so that's very restrictive too. Black crop key dots can be very restrictive in general. So can killer cages. So, but I just sort of went with the flow here, and it just led pretty straightforward to the solution. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.